And you're always going to kind of have to set this up first because it's not, obviously we don't have two sides congruent, so all three parts of your ratio are going to be different. But with 30 being the smallest of the angles, you're going to go directly opposite of that, and that's going to be your x. And then 60 would be the next, and directly opposite of that is actually where your radical appears, but it's not a radical 2. It is a radical 3. And opposite your 90 is 2x. So the worst part of this would be the x radical 3. Especially if you get a whole number for that side, you have to divide out the radical 3. Sometimes they're not so pretty, but you're going to follow the same steps that we did. If this helps for your notes, you might want to write down across from 30 degrees is x. Oops. Across from 60 degrees is x radical 3. Across from 90 is 2x. Okay, because if it's in this orientation, this won't always be your 30 at the bottom and your 60 at the top. And they won't always give you both. But you want to get in the habit, if you have a right triangle and you see a 30, you should automatically know the other one is a 60. Or if they give you the 60, you should know the other one's a 30. Okay, as long as it's a right triangle. So I'm going to start you out with a probably the easiest one. Okay, now in your assignments, these would probably be labeled with variables. I'm not going to put them in right now. We're just not going to worry about them. You can worry about them at the end when you're filling them out to check them. But you do the same thing we did with 45, 45, 90. You're going to go across from 30, and on the inside, put down that side would be x. Across from 60 is x radical 3. Hypotenuse is 2x. Okay, so you go straight to the side that you have, and you're going to set those two equal. So we know that x is 4. And if you start with x, so when you start with x, to find the others, plug x in. Okay, so best case scenario is this. We know x is 4, so we go down here to our side that has the radical 3, and if I plug in 4, what would that be? It'd be 4 radical 3. Okay, I just plug in for x. There's really nothing to simplify. And for this side, now you guys should be able to do this in your head, but 2x then would be 2 times 4, which would be 8. Okay, so those are my other two side lengths. Okay, so that's the easy case. We're going to do a couple variations of that. All right, so say this is the side that we have. Well, no, we'll hold off. We'll do one like that next. Let's make this 12. Right. So again, put in your ratios. Across from 30 is x. Across from 60 is x radical 3. Hypotenuse is 2x. Okay, so we're going to start right here. 2x equals 12. Okay, if you don't start with the side that's x, you're going to solve for x first. Okay, so if you get anything but the side across from the 30, you're going to solve for x so you can turn around and plug it in. Okay, so solving for x would have to be 6, which actually gives you one of your sides. That would be this. So when you solve for x, you're down to only having to find one more. So this side would be 6. And then we would go up to the side that's our x radical 3 and plug x in. So that should be 6 radical 3. So far, so good? All right. Worst case scenario. Okay. So put in your ratios. Start with the side you have. You can probably already look at this and know that this one is going to be ugly because your radical part is equal to a whole number, right? So we walk over here, x radical 3 equals 7. How do I get x? Now you can do it right to that, but if for your notes' sake you might want to rewrite so you can see exactly what you did. Sometimes going back when you already have all that stuff there is a little confusing. Okay, so if I divide out the radical 3, then I have this. Okay, so you do have to rationalize. So we multiply top and bottom by that radical. This would be 7 radical 3 over 3. And as long as 3 doesn't go into 7, that is x. Okay, so x is 7 radical 3 over 3. So that is actually one of your sides, yep.
Wouldn't you times 37?
No, you never take a whole number and a radical and throw anything into the radical. If they were both in radicals, you would then multiply them and they'd both go in. So if I had radical 7 times radical 3, then yes, they would go in together. But 7 is already a whole number, and you don't want to ever put something back in if it's not already in. So they just go side by side, and then your only concern is whatever that denominator is, does it go into the whole number on top? Okay, so this is actually 7 radical 3 over 3. And the last thing, which people don't always have an easy time with until you practice some of them, is this is x, right? So obviously we have to double it, but that's not a pretty thing to have to double. So as far as talking about doubling a fraction, if I had 2/5 and I doubled it, what would I have? I'd have 4/5. The only thing that changed is the numerator, right? But we've got that radical there to think about. If you remember back to algebra, the radical is kind of like it can be treated like a variable. If I added 2 radical 3 and 8 radical 3, I'd have 11 radical 3. So doubling it is only doubling the whole number, not the radical. So really, to double this, to do 7 radical 3 over 3 times 2, the only thing that really changes is that. Because the denominator just tells you what size your pieces are, and these 3 are really just multiplied. So if we didn't have the radical mixing with the 7 in the first place, it wouldn't when we doubled it. So this really is 14 radical 3 over 3, which will be your hypotenuse. Okay, this is about the worst that they will look. So don't panic if they, if they give you a whole number for the radical side of your ratio and the 3 doesn't go into that whole number, then it's going to look kind of ugly. Okay. All right. We're going to quickly go through a couple of homework problems.